This exercise asks us to make a conjecture about the value of the limit as x goes to 1 of x cubed minus 1 over x minus 1. The first thing we might do here is simply plug in 1 for x, right? Just say, okay, what happens when we actually hit 1? But notice if we plug in 1 for x down here, we get 1 minus 1, which is 0. And of course, we can't have 0 in the denominator. So we can never actually get to 1 with this function. But luckily, the limit doesn't care what actually happens at x equals 1. It cares what happens when we get close to 1 with x. So we use something like this table here to plug in all these different values as we get closer and closer to 1. So on the top row here, we're approaching from the left, right? We're getting closer and closer to 1 from the left. And then on the bottom row, we're approaching from the right, right? Closer and closer to 1 from the right. So you can tap furiously away on your calculator with this. I would recommend instead using Desmos.com, which is super useful for this kind of situation. So let's check out Desmos. So we can input this function into Desmos. We have x cubed minus 1, I'll just control all, divided by x minus 1. Okay, and there it is. And I'm gonna call this f of x equals. That's going to allow us to plug in all those values that you saw in that table for this function. Now, let's just look at this graph. First off, note that it's parabola, and we're interested in what happens around x equals 1. Okay, so let's zoom in a little bit here. Okay, so around x equals 1. So here's x equals 1 down here, so we're bringing it up, and you can get these coordinates here. And you can kind of see, so watch the x-coordinate, we're at 0.966, 0.981, and you can kind of see the y's 2.97, 2.979 as we get closer and closer up to x equals 1. Look what happens, whoops, at x equals 1. The circle, the dot turns into a circle, and it says 1. At 1, the y value is undefined. Everywhere else it's fine, right? And if you move quickly past it, you can't even see it. It's a single mathematical point that happens at. But yeah, right here we have problems at 1. Okay, so that's the idea here. So we can already see that y approaches 3 as x approaches 1, right? Just look at those y values. You can see it's moving right around 3, goes 2.9 something, and it's undefined, and then we're at 3.00 something. So it's clearly going to be 3. We still need to fill out that table. We know the answer is 3, but here's a quick way to fill out these kinds of tables when they ask. See how I've defined my function here, f of x equals, right? I included this f of x up here on the left. So now I simply do f of 0.9, and it tells us we get 2.71. So that's what would go in the table. Next, we want f of 0.99, so we say f of 0.99, enter, right, 2.97. And it's much quicker to do it this way than to sit tapping it into your calculator again and again and again. So here we go, f of 0.999, okay, 2.997, and finally f of 0.9999. Okay, and now you can see we're really getting close to 3, 2.9997. Okay, now we'll approach it from the other side. That's approaching from the left. We're approaching x equals 1 from the left. Now we'll approach it from the right. And again, I'm just following those values in our initial table. 1.1. Okay, 3.31 is what comes out. We'll try f of 1.01. Okay, 3.03. f of 1.001. 3.003. And finally, f of 1.0001. And that's the last thing the table asks us to calculate. And so 3.0003. So we can see very clearly that this thing is approaching 3. So back to our original exercise, we can conjecture that this limit is indeed 3. Right? Using the table of values. Now there are other ways we could have solved this. We could have factored it and then canceled out that denominator, but that's not what we're doing here. So eventually we'll do that with factoring, but for now let's just use the table and see what happens that way. It's a very direct method.